Okay, so the video crashed in the previous effort, so we will continue here. Okay, so I was saying that by using the sample function we will get 10 random rows from the matrix M, and now this will be a new matrix comprises a new matrix of dimensions 10 by as many by n column of M, so as many columns the matrix M has, but definitely it will have 10 rows because we sample 10 values, these 10 numbers here from 1 to 10. And the contents of this matrix will be exactly the same like the first row of M, then it will be exactly the same like the second row of M, and then again exactly the same like the second row of M. So these two rows will be exactly identical because here I have sampled 2 and 2, which means that I will get the second row from M and then the second row from M again, and then it will be the fifth row of M, and so on. Okay, so I have several ways to generate matrices from other matrices, from initial vectors, and so on. So let me explain how I will generate a matrix M from an initial vector. Let's say that I have the vector V, which is 100 values from 1 to 100, like that. And I want to, my task is to put these numbers here in a matrix form 20 by 5. So these are 100, 20 by 5, 20 rows, 5 columns. Now if I want to put them in this direction, so it will be 20 here, and then 21 up to 40, and then 41 up to 60, and so on and so forth, 81 to 100, then the only thing that I have to do is use the function matrix, and then the data that I want to put in 1 to 100, and then say that I want 20 rows equal here and m call equal to 5. Now the default here is to put things by column. So first fill the first column and then go to the second column and fill it, and then the third column and fill it, and so on. If for some reason, and this is in general the default behavior in R, so it treats matrices, when it works on matrices, it prefers to work on the columns of matrices. Just have this in mind. Now if what I need is the transpose of it, so to get a matrix like that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on up to 100, then I have to write matrix 1 to 100 again, 1 to 100, again, and row equals to 20, and column equals to 5, and then also specify that I want by row equals true. So this will try to put the numbers on this direction, filling first the first row and then the second row, and so on. Okay, so this is using the matrix function and a vector to put them in a matrix form. There is no need to use a vector of exactly the same size like the matrix. In a trivial way, if I will say something like that, then this will be a 20 by 5 matrix with zeros everywhere. Remember now that this in fact is not a scalar, but it's a vector of length 1. So what R does, what we have said that R does actually, is that circularly it goes through the vector. Okay, now it's trivial because it has only one element, so from 1 it will go first to 1, back to the 1, and then back to the first one, and then back to the first one, and it will fill this matrix. But if this vector is, if we use this function now, then we have a vector of length 2 here and a matrix of length 100. This is a multiple, 100 is a multiple of this. So what R will do is the following: 1, 2, so it goes by column, 1, 2, 1, 2, 1, 2, and so on, and then 1, 2 here, and 1, 2 here, and so on and so forth, up to 1 to here. So repeatedly it continues to repeat, putting this vector inside the matrix. Now if the dimensions of this vector do not fit inside the dimensions of the matrix, for example if this is 3, so this 3 is not a multiple of the number of rows, not a multiple of the number of columns, so it will have some problem here. But what R will do is that it will, in any case, it will try to put it here, but of course it will not be complete. So 1, 2, 3, and then 1. So these are 10 values. Okay, let's just make it 10 here, because it will be too much to put 20 values. So 10 values, and then we will continue here from 2, 3, 1, 2, 3, 1, 2, 3, 1, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, and then we will continue here 3, and so on. So you see, it ends here with 1 in the first column, and then it will continue here with a 2, the next element on the second column. It will show a warning, but it will create this matrix. Okay, so I have shown also this way to generate matrices. And now for the subsetting of matrices, again we can use similar ideas like the vectors. So we already saw how to get something like 1, 2, comma. This will be the first 2 rows, or comma 1, 2. This will be the first 2 columns. And now what I will use is the true-false notation to get subsets of the matrix. And usually these subsets are in a vector form. You will see why. So let's suppose that we have this 3 by 3 matrix with the elements 1, 0, 0, 1, 2, 3, 2, 0, 1. So this is a 3 by 3 matrix, 9 elements here, and I just want to get all the elements. My task is to get all the elements that are greater than 0. So this function here, this operation here, what it will return is a new matrix with true and false, and it will be true wherever this applies and false anywhere else. So it will be false, false, true, 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 false, true. Now, so this is this matrix. If I will put this inside the square bracket operators of the matrix, so this one, it will return all these elements that fulfill this requirement. So it will create a vector which will be 1. Now I'm not sure about the order. I guess it will be this order here: 1, 3, 2, 2, 1, 1. So I suppose that will be in this direction, and then this direction, then this direction, and not this direction. But I have to try it to find out which of the two ways is preferred in R. So subsetting with logical indices, so this is a logical matrix. It's also a very useful thing. To go from matrix to a vector with all elements that fulfill the requirement. Okay, so these are all about matrices.